Hi, everyone. This is Charles Hoskinson broadcasting live from warm, sunny Colorado. Today is Saturday, the 4th, and I'm just about to head up to Laramie, Wyoming to catch University of Wyoming, Montana State University game. And before I go up, I just figured I'd make a video and talk a little bit around some of the things that are coming and a little bit around some of the way we thought about how to build a good system. Now, the test net's out. People are actually playing around with it, and people are building all kinds of things. And as a consequence, some of the things that are being built in a very alpha way, to say the least. And so people are coming up with questions about access control. They're coming up with questions about concurrency. They're coming up with questions about throughput and capabilities of the system. The problem is that it's like somebody just takes their first computer science class and they learn about bubble sort and they say, God, why is my computer so slow? Well, because you're using bubble sort. It turns out that there's new, better algorithms that can be implemented, new, better methodologies and techniques that can be implemented. And what we've been trying to do as an ecosystem is balance speed of delivery to market with time for the development of tooling, pedagogy, and community-driven applications. So if we had all the time in the world, what would happen is you would have a very long testnet period, about a year. And you'd have lots of people come, tons of challenge problems, and there'd be this grand evolution in education of the underlying infrastructure. Now, we're in a competitive environment. There's tons of other protocols. A lot of people are moving very quickly. It doesn't make sense to do a long burn-in. So you can shorten that if you believe there are no safety concerns. And what you can do is create something on the mainnet where it's clear that there's a certain class of problems that are very easy to solve. And you now add lots of value to the system. And there's a set of other problems that the community is going to struggle with for a bit, probably about 3 to 6 months. And you let them struggle with those problems until those are resolved. So the purpose of this video is to, and it's going to be a little bit of a whiteboard video, is to kind of talk around where we started and where we're going and why Cardano was built the way it was built, and hopefully give you guys some more clarity on some things. So let's get right to it. And then I got to go. Okay. Wow. All right. So the first things first, I wrote a paper way back in the day. I think this was 2016, which is why Cardano. And in this, I talked a little bit about our design principles, various things that we were thinking about, various things we looked about. And I also talked about kind of two concepts. One was the idea of Cardano settlement layer and Cardano control or computation layers. Okay. So the basic idea is that no matter what computing model that we adopt in the main chain, there's going to be some use case pattern or cost or performance requirement or concurrency requirement that's not satisfied by that. And as a consequence, there's going to be somebody who's unhappy with whatever design change, design idea that we have. So they'd be a lot happier if they lived in a domain that's built bespoke for them. Okay, so the first thing is UTXO for accounting versus accounts. Okay. Now, the problem between these two, and this is hotly debated in the space, UTXO, Bitcoin follows, and there's a whole cohort of people playing around with that. And if accounts is what Ethereum does, it's almost like imperative versus functional. You know, functional programming language like Haskell versus imperative language versus JavaScript. There's just going to be radical differences of opinion about software design, development, accessibility, and what's the right tool for the job. So when we designed the system, we said, can we construct something that makes it easy to spawn off side chains that have different computing models? Okay, and different utility for the system. So for the purpose of this lecture, there's really three. Yella, the EVM, and Catalyst. Okay. So Catalyst is all about consent. And a complex collection of voting protocols. Now, if these voting protocols were to be developed with traditional EVM or Plutus style smart contracts, they'd be extremely expensive and heavy. So they're basically built into the chain. Okay, and there's a lot of MPC and all kinds of stuff going on here. And this is basically what we've been doing with Catalyst as a standalone chain. Now, the EVM, many of you watching who are Ethereum developers, you're familiar with this model. The whole Web3 concept, all the different libraries you like to use, all the different tools you like to use, all the layer 2 solutions. This is a vibrant ecosystem, and there's a lot of growth, and there's a lot of software that's already written there, and you guys are pretty comfortable with that. One of the big problems, though, is scalability here, principally because you have global concerns for the model to work. So basically, everybody has to know each other's business. The UTXO world, you have local concerns. You really only have to know your part of that graph to be able to do the things you want to do, and you preserve inclusive accountability. So when you want to do things like shard and scale, you want to do off-chain stuff, you have a lot of non-determinism. Here you have absolute determinism. And you have a lot of concerns of exactly how to address that, deal with that. This is one of the reasons why ETH2 is such a complex piece of software and why they're having such trouble getting these out. This is not an easy problem, and kudos to them for thinking about it and trying to solve it. However, because you have global concern, you have a slightly easier time as long as you're willing to accept these trade-offs with things like concurrency and things like event handling. But at the end of the rainbow, almost all the solutions that actually in practice deal with this because of cost and scale, they have to deal with this as off-chain, some sort of layer 2 or centralized solution. This is why a lot of people actually, when they say DeFi, they say, actually, we're talking about CeFi. Because in practice, to make these things cost effective and scale, we actually need to introduce some centralized components. Okay. Now, Yella is a different thing. Yella is actually a register-based assembly, and it's based on LLVM, which is a very well understood model that came out, I believe, in 2003. And it's really built on top of the entire K stack, K technology stack. And this has always been something that I've really liked and wanted to enjoy. The concept here is really universality. K has always been a kind of a meta programming language. So really the idea is something like the JVM or the CLR, something that is sufficiently complex enough that we could actually have a real conversation with a straight face about eventually C support and C++ support and other mainstream languages, and have a path and a process to basically get there. Hang on a second. All right. So let me just kill that real quick. So the point of the settlement layer and the way that Plutus and extended UTXO were designed is we had some principles with this. We said, okay, well, there's going to be these different computing models, specialized computing models for governance that are very, very heavy and resource intensive and run very deep protocols that cannot be replicated with the standard smart contract model, even with UTXO and all the optimizations we could potentially do there, or with this account-based model with Ethereum, or anything we can do in Yella. If we want to copy Ethereum, we need a special sandbox to do that and allow that to co-evolve with how Ethereum evolves. And if we want to chase new concepts like Yella, which is a new concept to the industry, and all the power that K gives us, and we want to chase universality, then we're going to need some sort of connection point for that. Okay, so the first goal of Plutus was really pushing for CSL to CCL interoperability. Okay, so basically the idea is that assets, information, users have a easy method of flowing between the different systems and calling between the different systems. So as sidechains turn on, you can do your computation off the main chain. You can do it inside the computation layer. For that, you can call it, and then results can flow back and forth. Here, this kind of is beating at a methodical pace. Okay, so basically you have a block every so often. It's like a heartbeat, and that's your unit of change. And these unit of change, they can be batched. You can get much more efficient. You can compress things. You can use compressed representations. You can do things like, for example, be very clever. You can use NFTs for access control. There's a lovely blog post floating around about this. Okay. And then in terms of concurrency, you can actually distribute amongst many UTXOs. Okay. And then you also can do off-chain processing, like Ethereum does in practice. But you can't get around the fact that there's a consistent, reliable, semi-synchronous heartbeat that the system has. This is a fundamental design principle of most blockchain systems, Bitcoin, Ethereum, other things. And there's all kinds of things you can do. There's all kinds of things you can do to make things more efficient, to be more clever about resource utilization, and how you represent information and what you're actually processing on chain, about how people have right of access and how access control is going to work, and how distribution amongst the UTXOs is going to work. But you still always, regardless of the blockchain system you're using, if you choose to use a block-based system for change, you're going to have this methodical pace, this flow that happens. Now, you can get very clever, and you can put some pre-processing into the stake pools, and they can do all kinds of things to handle event flow and concurrency before some change gets committed. Or you actually can run things in a dedicated channel. And this is kind of the idea of Hydra. Hydra says, oh, okay, so we're going to have stuff that happens on chain and off chain. All right, well, that's actually starting to get sensible. So we have these things that are occurring, and somewhere around here, we're going to go into this kind of domain. It's going to have lots of users interfacing with the domain. They're going to have a lot of fun. And then at some point, those changes get committed as a single batch transaction on chain. Now, you can do such a thing if you've designed your accounting model and your programming model, as we did with extended UTXO and Plutus, to work with the layer 2 solution. One of the reasons why Lightning is having a lot of trouble with this type of process is that the programmability of Bitcoin script is extremely limited. Plutus is actually a general purpose programming language in a certain respect. It's a DSL that looks a lot like Haskell, and it is Turing complete. Now, the thing about it is that when we're doing this, you build this like a spiral. And I'll show you where we're at. So when we started this, it was just good old-fashioned push transactions in Byron, just like Bitcoin. And then we started adding some more sophistication. We added in metadata. And then suddenly you can put payloads into the transaction. And this enabled things like the Ethiopia deal and Beef Chain, and a litany of other things like supply chain management. Why? Because you can now embed into the transaction metadata that the system doesn't care about, but your application does care about. So DIDs are the canonical metadata. Identity travels on the wire. Then you have, next step, user issued assets. So the Cardano native asset standard. And what are you guys doing? You're issuing tens of thousands of NFTs, because that's right now the level of sophistication our native assets have. And now we actually have the next step where we're introducing on-chain Plutus smart contracts. Okay, and this is huge because first off, it allows the interoperability bridges to occur. So when sidechains start materializing, centralized and decentralized, you can start moving assets, information, and users between them, including Ethereum sidechains. Okay, so all that stuff you guys are used to in that world, it now can work. Okay, so you have interoperability enabled. Okay, you have things like spending policy. So you can issue significantly more for tokens. You can issue significantly more complex tokens, not NFTs, which are kind of passive things. Now you can do things like a stable coin. So you guys may have seen the DJED paper, the paper on an algorithmic stablecoin. This is an example. You can now use Marlowe. So that's going to be rolling out as the PAB gets integrated and these things get worked. And so basically now you can have very complex financial contracts. But because they're written in Marlowe, they're simple to write, and they enjoy determinism. So you understand your resource costs, security. They enjoy safety and execution and a litany of other things. Okay. Now there's open questions about, well, what about DEXs? Well, yeah, you can do DEXs. And actually one of the DEXs in the ecosystem, Occamfi, wrote 2 articles. One was in July saying, hey, we're thinking about concurrency. And they kind of talk about some of the challenges. Then they read another article, just came out today, 2 weeks ago, August 18th. They say, actually, we're ready for concurrency. We figured it out. You see, and why? How did they figure it out? Well, there's a lot of different ways to do it. And I probably am guessing that they are using some sort of off-chain batching mechanism and event handler and serializer to accommodate that, and then efficiently committing things once they've settled on the off-chain infrastructure, on the on-chain infrastructure. And that's okay. That's actually how Plutus was designed. Stuff happens on-chain, stuff happens off-chain. You can write both. You can think carefully about both. Some solutions are somewhat centralized. Some solutions are not centralized. But guys, your imagination is limiting you if you think that, well, we can only do one thing every block pace. No, you can either distribute the UTXO, or you can be very clever about using off-chain infrastructure for batching, or we can introduce more complicated concepts over time. That's the point of the spiral. You see, here we're safe. We've achieved something that's amazing. Smart contracts on a UTXO model. Had Bitcoin had this capability, Ethereum would not exist. That's what we basically did. We solved a 12-year-old problem that Satoshi couldn't solve, and we brought that into the UTXO model. This is a safe programmability of UTXO. But that doesn't mean that that particular solution is the end-all be-all, because there's going to be all kinds of patterns like oracles and dexes and other things that need to be thought carefully about. And there's always going to be this balance of what do you run off-chain and what do you run on-chain? And that always comes down to concurrency, operating cost, and it comes down to security and trust. Okay, these are your factors. Whether you're Ethereum or Cardano, you have to think about this as an application developer. Oracles, for example, you could do completely on-chain oracles and make them completely deterministic. That means all that data has to be committed to the chain. So, for example, let's say the price of ADA to USD. Well, what if you're doing that every block? You're adding an enormous amount of bloat to the system. Well, you could do a completely off-chain system. All right, well, that's a different trust model. Maybe you federate it to improve the model. Maybe you introduce bonds or other mechanisms or punishments to improve the veracity of the model. You see, but then it's all about access to that off chain. Can a smart contract query it and talk to it? We have to build some mechanism for that. So you need some sort of bridge for it. Oh, okay. Well, these are design considerations that you have when you actually put an oracle together. The same for a DEX. Where is the batching happening? The batching and matching. You can always choose the bubble sort and use the slowest possible method and say, oh, yeah, the way I wrote it, only one transaction can happen per block. Sure, that's absolutely possible. You also can come up with very clever off-chain ways of doing it. Now, as we get a little further along and we add the computation layers, what gets really exciting is you now have emergent interactions. Okay, so for example, you can have an EVM style smart contract. And that EVM smart contract can now call and talk to a Plutus contract and vice versa. So maybe it's easier in your mind to do the batching and matching and these other types of things on an account-based model because you just understand that and you want to do that. Great. You can leave the value here and use this as the control contract that actually handles it with all the user interactions. Well, what's our advantage over Ethereum? Well, one of the really cool things about having a root of trust is this is the single most expensive thing to establish in a cryptocurrency. Proof of work does this for Bitcoin, and it costs billions of dollars every year and massive amounts of electricity. Okay. But once you have that root of trust, you can then use it as a guarantee and then build efficient light infrastructure above it. Okay, so I'll give you an example. Right now, Ethereum uses proof of work to establish the root of trust. They're trying to move to a proof of stake system because they know once they have that, they can shard and have different computation domains. Starting to look like a Cardano style architecture now, isn't it? Well, wait a minute here. We have Ouroboros. And right now we're running Prouse. This year we'll likely upgrade to Genesis. And then we'll do a little bit of optimization to that. But once you have that as our root of trust, why can't we run OBFT, a significantly faster protocol that presumes a trusted quorum, and use the SPOs as the quorum? Well, wait a minute here. Now we're running a BFT protocol. These things have been shown to operate in the 1,000 TPS or better range. And there's papers like Rapid Chain that talk about how to shard OBFT. Plus, you can run them concurrently, right? Because you can use the same SPO set to run many different chains. Sorry, my pen is acting up today. So you could run copy 1, copy 2, and load balance and so forth. Well, that's actually quite easy to do. And we have something called Mamba that we've been working on specifically for Ethereum support and ELA support. And we're going to talk about that at the conference on the 25th. And you betcha we're definitely looking at using OBFT led by the SPOs. Okay, so if you're running much faster and you don't have to worry about the selection of the people, you have a stable quorum, you can highly optimize, and your trust model is actually reduced to the trust model of Ouroboros. So you're not actually changing the underlying trust model that we already have for Cardano. So by having this strong root, you can do this and you can replicate many chains. So we can use OBFT for Yella, we can use OBFT for EVM, but here's where it gets really wonky. You can use OBFT for Plutus. Why? Well, Cardano can be a side chain to itself. So you can run a high efficiency model, and you can even have different models. Like, for example, people like DAGs. They like these block trees. They like graphs. They like all kinds of crazy stuff about how to handle blocks in parallel. And in fact, we wrote a paper called Parallel Chains. Okay. And there's a lot of follow-up work there. There's a paper called Prism, which actually talks a lot about this by Pramod. It's not to be confused with our Prism paper, the Swanath. And it talks about actually how to create parallelism. So you actually do all of these things at the same time. All right, so having this heterogeneous model with stake pools as the root of trust that are always increasing means you can use them to replicate new chains, new resource models. It's a win-win for them because guess what they get? They get more revenue streams. They make more money because they're actually running multiple pieces of infrastructure and lots of parallel transactions and so forth. Okay, so that's the point. That's later in the spiral. But the point is that the spiral, each step of the way is secure, and each step of the way doesn't cause a mass disruption. And we just kind of grow on the spiral. And what happens is you get faster and faster and faster. So, for example, Mamba, the plan about sidechains that we've been pushing, that is running concurrently with Hydra, which is the other scalability solution, the layer 2 scalability solution, which is running concurrently with an optimization plan that we have to basically compress some more things and speed up some things and increase block sizes and so forth to improve the performance on the main chain. And that's running concurrently with Blue Ocean research, like, for example, concurrent state machines. And what's really cool is what's going to happen is all of these solutions. So there's right now 8 development companies we got together. And I think 7 of them are going to be presenting at the conference. And we asked them, go build a DEX, okay? And go build an Oracle and go build a lot of different stuff. They're actually going to be showing their code, show code, and doing tutorials and talking about their experiences. The good, the bad, and the ugly. Okay, so that creates a feedback loop. And that feedback loop basically gives us more ideas about new features. So, for example, you'll see in Ergo, they have this concept of read-only UTXO. That's an idea. And there's dozens of potential new features. You could do pre-processing to actually take some of that processing that would be done with off-chain infrastructure for ordering and batching. And you actually could put something like that into the SPOs. Okay, so there's a feedback loop that now exists with the thousands of Plutus pioneers and the companies that are actually building on Cardano where we can add them. And, these 2 things, this one and this one, it's about 6 to 12 months. So about 2 to 4 HFC events because we average an HFC event every quarter. I think there's going to be 3 this year, but we'd like to get into a habit about 4. So there's 6 to 12 months of taking it for a spin. And what will happen is you have all these people that are just so dishonest and just toxic assholes who say, well, what Charles is saying is Cardano won't be useful for 6 to 12 months. No, I didn't say that at all. At this juncture right here, you guys can do pretty much anything a Turing complete smart contract can do. We're going to have stable coins materializing. We're going to have interoperability materializing. You can do all kinds of locking mechanisms for multi-sig. You could start connecting centralized off-chain infrastructure. In fact, DC Spark is planning on doing that. You can run complex financial contracts, and we're actually a pretty efficient system. And all of our benchmarking shows about 2 orders of magnitude cheaper than Ethereum right now. And this month, those things will be solidified. And absolutely, there's going to be some creative decisions that have to be made with oracles and dexes. And partners have already started making some of those creative decisions. And those things will work their way into production this year and next year. And are they super efficient? Well, of course not. Why? Because it's a new model. No one has ever done extended UTXO before and Plutus before outside of Ergo. And at the scale we're doing it, no one's ever done that before. The point is that you want to establish a stable root of trust. That's what we've done here, and have enough programmability at the settlement layer where you can get people connected to the domains that they want to be and also move large amounts of value efficiently. You can represent and move value efficiently. Okay, that's why we created Marlowe. You see, Cardano is going to be, in our view, a dominant platform for lending, for insurance, for bond issuance, for all kinds of financial products. Now, when you talk about rich interactive experiences involving millions of concurrent users, blockchains are not built for that. Ethereum isn't built for that. Cardano is not built for that. That's not the point of these types of systems. You need bespoke domains for those types of systems. And those bespoke domains all have their trade-offs and their assumptions about how they run. If you're really clever about your design and your model, then what you can do is you can use the fact that you've created a very strong root of trust to instantiate those bespoke domains with different economics and different ideas, and then suddenly you can utilize them. But what's really nice about that is this concept of encapsulation. So not every one of these bespoke domains will be successful. And let's say one of them collapses or has a problem or a flaw. That doesn't cascade back to the main chain. So the billions of dollars of value that's on the main chain and the settlement layer is never really disrupted. You say, but Charles, well, what about the fuel source and things like, well, guess what you can do? You can say, okay, well, the same mechanism that allows token locking, the same mechanism that allows staking, the same mechanism that allows voting, you can use this to generate an alternative fuel with different economics on the sidechain. Okay, so sky is the limit. You can put in demurrage, you can put in, where the tokens expire, you can put in infinite inflation, you can do all kinds of crazy shit that you want on that new chain. Well, ADA will never leave the main chain, but yet it generates new fuel on the sidechain. So let's say that that sidechain has a tragic economic flaw and that thing collapses. Is your ADA harmed? No. Your ADA is A-okay. You see, and that's the beauty, and that's the magic of what we've constructed here. When you want to do mass acceleration of smart contracts, you're going to need off-chain processing like Hydra. You're going to need things like optimistic rollups and state channels. These are just facts of life, which is why Ethereum is investing so many millions of dollars into them and thinking about these things. This is not something that makes sense on the main chain. You just can't build these systems in a way where they scale at billions of transactions per second on one system. You have to divide and conquer. You have to batch. You have to pre-process. You have to move things into different domains. Some things aren't going to live there forever. And also, if you just use common sense, what does it mean if your average transaction size is 0.5 kilobyte? Let's do some simple math here. Okay, so every 2 transactions, you have 1 kilobyte. Okay, so let's scale it out. Let's go to 2,000 transactions. Well, now we're at 1 megabyte. Uh-oh. You see what's going on here? Let's go to 2 million transactions. Now we're at 1 gigabyte. So if you're processing millions of TPS, you're actually saying that your blocks are in the gigabyte size every second. Where does that go in 1 month? Where does that go in 1 year? Where did that go in 10 years? What is the weight of the blockchain if all of these things are immutable and never go away and they stay there forever? You say, oh, well, no, that's not completely accurate because we're going to batch them and we're going to put compressed representations like hashes or use zero knowledge proofs, or we're going to do off-chain processing. Well, then guess what? You're in my model. You're in my model. You're here. You're here with the computation layers. You're here with the settlement layer, right? You're here with Hydra. And what we did is we thought about this very carefully. It took 6 years of careful thought of saying, how do we pull in 35 years of knowledge from the functional programming space, because we want to do things like high assurance development. We want to do things like resource determinism. We want to do things like local processing, as opposed to having to know the global state of the system and introducing non-determinism, these types of things. We wanted to account for a rich metadata standard. We wanted to account for native assets. And the point of the 12th is now to turn on the single most important feature, which is the on-chain smart contract component. And then you have things like the Plutus application backend, which is off-chain infrastructure. And you have things like off-chain processing. You have canonical design patterns that come in. Those are built over time with the community to accommodate that finite, scarce resource, that heartbeat that you have, just like it was with Ethereum and just like it shall be with us. The difference is we have built in the keys to the Holy Grail, which is we have a strong root of trust, which means we can instantiate many solutions and encapsulate them. And if those new solutions fail, they don't blow back and destroy the main chain. It protects the users in a certain respect. Furthermore, there already are people building. Occam's building. Dozens of others are building well-financed projects. And over the next 3 to 6 months, those developers will bring those 1.0s, turn them on into Cardano. Now, we could have done all of that on the testnet and had a rich long-term testnet time period. But that means then we're delaying stable coins. We're delaying interoperability. We're delaying connecting sidechains on. We're delaying spending policies for your tokens. We're delaying your ability to do bonds and security tokens and all kinds of things by waiting for those applications to build some of this canonical infrastructure. There's no safety concern for doing a hard fork combinator event. Plutus is a safe thing. We have a very good understanding of it. And we've gotten to a point where we feel pretty good about it. So we actually can move quickly here. But what that does mean is it takes a little bit more time for canonical approaches to solidify. And then you end up having what always happens. You have abstraction, where tough implementation details you no longer have to worry about. You have templates, okay, where other people solve the problem for you and you borrow those particular solutions. You have services. Okay, there's tons of off-chain services like Infura and Fireblocks and all these other things that exist in the Ethereum ecosystem. Why? Because they need to do this off-chain stuff. They need to have a management layer for these types of things, especially if you're in a light client environment. Okay, you have standards and APIs. Okay, you have all kinds of these types of things develop, design patterns. And that will be built by the Plutus pioneers, the Plutus core team, and built by the application developers in the Cardano ecosystem. Now, each of these start handling problems like concurrency and access control and all kinds of things like that. Already, there's several people using NFTs for access control to create unique identifiers for the contract and unique identifiers for the different parts of the different users of the system. And the NFTs are ephemeral; they can be destroyed easily, created easily because of the native asset standard. It's a very novel way of using that for extended UTXO. And of course, every step of the way, optimization occurs. Your operating cost gets reduced. And the other thing is this model is super amenable to security and predictability. So at the conference, I think we have 4 vendors that are going to be talking about formal verification of smart contracts. Okay, so for the first time in a while, people are starting to take this seriously, and this model is amenable to that. And you have an upgrade cycle, you see. There'll be probably one more HFC event before the end of the year, and then that's going to be adding a lot of capabilities and functionality and emergent things that we've learned. And at some point next year, the CCLs are going to turn on, and you're going to have decentralized sidechains that add in programmability from the account-based model and from the Yella-based model, and also Catalyst for bespoke computation. So all of a sudden, you can take really complex governance and put it there. By the way, you also can do a super complicated DEX as a sidechain, and you can put in all kinds of bespoke features for that, just like we did for Catalyst. It's just a sensible model. And if there's enough commercial demand, enough commercial activity, it makes sense to do that. And you just keep living on the spiral. What makes Cardano fun and unique is this is an interactive process. It's a participatory process by you, the community, and it's a friction-free process. We know come September 12th, it's going to be a pretty easy upgrade, all things considered. Certainly could be an issue, but it's probably going to be an easy upgrade. And we know the use of this system is not going to break or regress Cardano in ways where you wake up and the system is suddenly unusable. The existence of it creates new challenges, like the shipping of Shelley created the demand for proxy keys and counts and partial delegation. And there's a lot of work at the ledger rule level that has to be done to accommodate that. And so that's being rolled out. But once that gets done, we'll be best in class in that respect. And similarly, there's a lot of little things that have to be resolved with the launch of Plutus that will enable more and more things. The problem our industry has is they basically say, well, if you don't support my thing, or I can't see a way to make my thing work, what you have constructed is absolutely useless, forever useless, and is just a toy. And then they use vanity metrics, not even understanding what they're saying. You're only at this performance level. You only do, well, increase the block size. Oh, well, okay. They don't really understand how all these components are interconnected to each other, interoperate with each other. What they really don't understand is the single hardest thing to do, and this is what Bitcoin solved, and it's why it's worth $1 trillion, is the establishment of a root of trust. What Cardano has done is be the largest proof of stake system in the world with an efficient root of trust, with a beautiful model that will make it easy to roll out computation layers. This was the goal that we wrote down. I actually wrote the paper, but this right here, why Cardano, back in 2016. I said, we want to have this idea of a computation layer. We want to design in layers. This is the notion. We need to somehow figure this out. And it was a humongous technical challenge, and there were a lot of moving pieces to it. And what we've done is we've basically figured that out. And now it's just a matter of deciding the most efficient connection protocols, implementing things like Mithril. And we'll have an update on Mithril, for example. That's another one of those concurrent projects we have here that will assist in this entire process. And now, because we have a stable foundation, we can work in parallel. Different teams can do things, competing teams can do things. And by the way, competing teams was one of the design principles that we have. A heavy use of interdisciplinary team and InfoSec, fast iteration, competing teams. These were some of the design goals that we had inside this the setup for Cardano, and we're achieving that now because of the architecture. But Reddit won't agree, Telegram won't agree, Twitter won't agree. Guys, it's noise and it's FUD. It is one of the hardest things in the world to build a truly scalable, distributed system that is decentralized and admits Byzantine actors, and to make that system programmable. It's so hard that the Bitcoin community for over 12 years has been trying to figure out how to do that in a way that they consider to be safe. We, as a project, took an enormous amount of inspiration from the successes of Bitcoin and the successes of Ethereum and a lot of the ideas that have come out of the third generation. And what we tried to do is put together a representative sample of the best things that we think. For example, most of the flaws that we see in DeFi and historically in Ethereum smart contracts come in trying to deal with complicated financial arrangements. That's why we created a DSL to make those simple and safe. You need to admit that there's a world outside of your system. So you need the ability to batch and match and process off-chain. So we built that right into the system and into the language. And we're showing people how to do that with the Plutus Pioneers program. And all these applications are coming up with that. We wanted to connect to the formal methods and high assurance world. So we chose a functional language as the entry point so that there'd be a significantly easier and lower cost path to do that level of verification, because there's so many hacks and flaws and other such things. Concurrency comes naturally. It comes either with off-chain interaction, state channels. It comes with concurrent state machines, and there's ways to do that. They can be brought in. It comes with clever load balancing of different UTXOs, linking them together with NFTs. There's all kinds of design patterns that you can do. And we spent the money to bring in different independent development firms to build things, because those firms are going to solve things in a different way. And they make that code available to all of you, not in 6 years, but this month and next month and the month after. And there's a stack exchange, Cardano Stack Exchange. People can ask questions. And if you still don't like the model, well, then just take the other model that you guys like. There you go. And just live in that model. And all that tooling is reusable. But the difference is they run on proof of work right now, and they're super fucking expensive. And we're going to run on OBFT right now. That's kind of like what Binance Smart Chain is doing. It's a lot fucking cheaper. Okay, everybody gets a cow. Everybody gets a chicken in every pot. That's the way we built the damn thing. Okay. And what we're shipping on the 12th is a massive, massive upgrade because you can now have full programmability. You now have spending policy. You now have interoperability. We can do stable coins. You can do Marlowe. These things all will come naturally. And yes, DEXs will be here. Yes, oracles will be here. And they'll certainly have all kinds of cool features and functionality there. Now, it'll take time for those things to mature, become more cost effective and efficient. And that's just a natural evolution of the system. And our users have confidence that'll come because they see the spiral and they understand each part of the spiral is a new update, a new upgrade, these types of things. And they've seen it happen before. And what's nice is parallelism comes. As you get deeper in the spiral, you can now do more things at the same time. And we already see in practice the application of intensive, high computation, high expense stuff being done in bespoke domains. And those domains will get connected onto Cardano. None of this was possible before Plutus existed. And now that it does, all of these things are possible. Okay? You don't throw out all the innovations of the last 12 years. You don't throw out the concept of a blockchain and what Bitcoin has accomplished in that methodical pace. You don't throw out all the security models that have been painstakingly figured out. You don't throw out all kinds of stuff just because some junior developer can't figure out how to do something. What you have to do is you have to teach them and you have to show them and you have to build the infrastructure. You have to build the tools. You have to build the abstractions. You have to build the services. Okay. And these are economic opportunities, especially on the services side. USPOs, you keep saying we need more money. We want to make more money. Well, guess who's going to be the blockchain as a service provider for a lot of these things? You guys. It'll be done in a federated network. It's just another revenue stream at some point. That's the power of Cardano. And because we thought about it carefully, we get things like Babel fees. We get more predictable fees. We get resource determinism. We get local processing, a significantly easier time sharding. God, it's going to be fun to run sharding experiments with Plutus and parallel chains. We can do that. And we have a model for how to roll that out, at first as a disconnected side chain and eventually as a connected chain. And it's the very same thing that Mamba is going to give us with EVM will give us that. Okay. All of that comes and it's built into the design of the system. It's built into the evolution of the system and you regress nothing. You don't lose the security model where it costs tens of billions of dollars to attack the system. You don't lose the upgradability. You don't lose the native asset standard. You don't lose the metadata standard. You don't lose all the tooling that's being built for Plutus and all the formal verification capabilities for Plutus. You don't lose all the new design models. And if it takes an additional 6 months to add a new computation model, that just means those developers will do something else for that 6 months. And when you have it, you have it. This is a marathon. It's not a sprint. And if I am being told the only way for a system to compete is it has to have everything today, then first off, I'll ask, what real life massive change has occurred because of blockchain in our industry? Are we running the internet on blockchain? Are we running our national ID system, your voting system, your supply chain system, your stock markets, your central banks' currencies on blockchain quite yet? The intellectually honest answer is no. And the reality is these changes will take years to decades to percolate through society. There are no standards in the industry yet. The so-called market standard Ethereum is literally upgrading itself to a radically different design. And interoperability, well, the things that they're going to keep the same, we will have. So it's all going to be commoditized and it's going to be about cost, ease of development. It's going to be about maintenance cost, the life cycle, the security model, and also product market fit, the marketplaces that you're in. Cardano has always been the project where we've tried very hard to balance all of these things and not be everything to everybody, but understand how people can self-serve and they can add capabilities and functionalities to it. So if you want specific tutorials on concurrency, they're coming and they'll come as early as the conference because you're actually going to see running live code of the different development companies that have come in. If you want a detailed information on how to be an app developer, well, we've already done 2 cohorts of the Plutus Pioneers program. The third one will probably be the best because it's the first that'll have the PAB integrated with it. That PAB integration will be in beta state in September 10th, and we'll keep adding to it. And then over time, interoperability comes and side chains come in. Partners are building like DC Spark, and we're building them too. And that adds the legacy programming models that a lot of you developers are comfortable with, and it's there. And then what's really cool is you'll have interoperability between these systems so they can start talking and calling each other. And yeah, sure, a lot of clever infrastructure has to be built, and we have to keep upgrading the PAB and all types of things. Sure, that'll come. It's a process. And uh, every day we get a little bit better. Every day we get a little bit stronger, and there's more utility inside the system, but no regressions in the system. There is no notion of a radical change where we have to throw out everything and build a Cardano 2. Really, no, it's more of a spiral. That's always been the point, and you just keep adding and adding and adding and adding and adding and adding, and you have the intellectual honesty to admit the wins of the past. Bitcoin was a huge win. UTXO makes a lot of sense for a settlement layer. There are different accounting models. There are equivalencies between accounting models, in some cases, non-equivalencies. So it makes sense to permit diversity, and that's what we do with CSL and CCL. And we wrote that down in 2016, explaining that to everybody. Okay, this was not exactly a new concept. It's been around for quite some time. And I think it was published in English in 2017. So you've had 4 years to kind of know about that. And everything is built out in the open. It's all transparent. Code of the pioneers and all these other people. So it's my Saturday. I now have to go up to Laramie. I will see you guys later. I have to go quickly, but because I don't want to miss the kickoff. But I hope this helps people a little bit keep their eye on the prize and understand where we're at, what's going on. The 12th is a major day, but it is just a day. Just like Mary was a major day, Shelley was a major day, and there's many more to come. There is a nice pulse of innovation, and we're getting that into a quarterly cadence where major changes can be made. Quarterly, minor changes are made, intermediate, and it's a two-way relationship. There was a lot of people building things. As those things are built, those buildings will change in underlying infrastructure, and a lot of experimentation is going to happen. But every time that happens, it's done with safety in mind, predictability in mind, and stability in mind, so that you don't have mass regressions. Certainly a lot of things that I'd like to be sped up, especially on the wallet side. And I'd certainly like a better light client experience. These are high priorities, and you just invest, you hire great teams and you work at it for a long time. The hard part was figuring out the flow. How do you write great papers? How do you write high assurance code? How do you get predictable releases? How do you get upgradability? How do you build a great community? All of those wins aren't going away. They're here. And that's the single hardest component. Everything else is implementation details, off-chain infrastructure, on-chain infrastructure, augmentations to Plutus, these types of things. But what's nice is there's some degree of stability and predictability about things. One of the reasons why I love Wolfram as a partner, if you look at the Wolfram language, there's been a remarkable commitment to backward compatibility there. Some of the stuff in I think it's the 80s, still runs on their infrastructure today, even though they've added so many new capabilities and features and magic in Wolfram's plan. And that was not by accident. It was by dogged design and commitment. And it's the same situation here. Your Byron transactions will always run. Your Shelley transactions will always run. And now we're in Goguen era. And there's many more things to do, many more things to add, but those capabilities are there. That's a magical thing for us as an ecosystem. And that's what we're doing. So I hope this helps a little bit. And as I said, there's a time and a place for these technical conversations. And I feel workshops are the best place to do that. I feel training is the best place to do that. That's why we have the Plutus Pioneer Program. That's why 3,000 people have run through it. That's why hackathons exist. That's why Cardano Stack Exchange exists. Everybody over the internet, there's a lot of people out there that are cynical assholes. And no matter what we announce, what we do, they're just going to poo-poo it. Either because they don't understand it, they don't like it, they don't value it, or they have an economic incentive to lie. It's one of those categories. So I hope this helps a bit. One of the gifts I got recently was, let me go ahead and kill the screen share. One of the gifts I got recently was Happapus, Happy Octopus, and you can flip it around. and you get Statipus. And, some days we're Happapus and some days we're Statipus. But you can't take things too seriously. Most people do, and unfortunately, that's why a lot of problems materialize in the world. We're having fun. It's a beautiful ecosystem, and there's a lot of great people and a lot of great things being constructed. The point of Cardano is to be around in 50 years or 100 years. We got the model of innovation right, and we got the model of collaboration right. That is more important than anything else. All the other stuff, it's inevitable. It'll happen. Might take months, might take weeks, might take years, but it'll happen. And if you don't like the model, well, eventually you can add your own. And what we've done is, I think, the most balanced hybridization between the innovations of Bitcoin and the innovations of Ethereum, with an eye on how do we achieve the third generation? How do we achieve scale, governance, and interoperability? And I'm pretty happy about that model. And there's 500 people in my company, well over, I think, 200 at this point, are working full-time on nothing but Cardano. And there's 12 other development companies that are working on infrastructure in Cardano. Everything from ledger support to hardcore stuff on the network stack. And there's a whole constellation of people now building dApps and so forth. And there's Catalyst with $1 billion available and all kinds of people voting. That's not going away. That's only going to add and add and add. The model that we've developed has the ability to absorb those business and technical requirements and upgrade and scale up the system. Now, every now and then there are checkpoints. The Cardano 360 is a checkpoint. The conference on the 25th is a checkpoint. And as that model matures and materializes and gets really strong, next year the foundation can do tons of hackathons to encourage more developers, and that'll happen. In addition, we're seeing no indication of slowdown on Catalyst and projects and programs and people. There's a lot of push there. One thing I'll never succumb to is cynicism. When you have a $100 billion ecosystem, you have to be very careful and delicate about how quickly innovation is pushed and how quickly you add features and functionality, or else you run into a lot of problems. What we've been able to balance is that reality with the absolute need to keep moving forward aggressively, which is why consistently we've been #1 in GitHub commits. And I know, read it again and again and again. Oh, but those mean nothing. Those mean nothing. Those can be gamed. Guys, we're not pushing trivial commits where we're like, oh, well, we changed the variable name for the string. This is real commits. This is real code. Anytime someone says that, you ask them to go through the commits and identify which ones are superfluous. It's an indication of a massive collective engineering effort at a scale this space hasn't seen before. We're moving, frankly, faster than most people. Ethereum is still trying to figure out how to build that proof of stake root of trust. Not only are we there, ours is secured in the tens of billions. And it has a beautiful upgrade path, and we clearly understand where Ouroboros needs to go. And we also understand how to build secondary chains that can connect on. They're still working on that. The programming model that we have at times can be a bit inflexible and restrictive, but it was built specifically for interoperability and for the movement of vast amounts of value and for safety, verification, resource determinism, inclusive accountability, and the requirement of only local state, not global. Okay, so given that that was the design space for version 1, it's unreasonable to go ahead and say, well, it doesn't do X, or, well, it's hard to do X right now. That'll come. And it's a natural organic progression of these things. And you enjoy all the things that we've already achieved and accomplished as an ecosystem. If you can't get that, maybe this isn't the ecosystem for you. Go somewhere else. If you think everybody else has already solved these problems, you're being lied to. These are some of the hardest engineering problems in the world. They're not going to be solved for decades because there's only partial solutions. And every iteration is another example of a slightly wider solution that we have. Okay? That's where we live as an ecosystem in a space. That's why Bitcoin doesn't have smart contracts like Ethereum does or Cardano does at the base layer. Not for lack of trying. Look at Taproot, look at Simplicity and their jets and all these other things that they're doing. There are a lot of really smart people in that ecosystem who hold great credentials and have been doing this for over a decade, who are really, really trying to add these things in. But they understand there's $1 trillion at risk and they only get one shot. And if it's done incorrectly, all goes to hell. It's a hard situation to be in. So you can only move at a glacial pace. What we found out how to do as an ecosystem is be able to upgrade value like that, but move at a much faster pace. So we can out-evolve them over time and do it in a very inclusive way where you get a say through Catalyst, and do it in a way where the universities are involved and the application developers involved. There's a beautiful feedback loop of community commentary that comes through, and very well qualified people with very strong opinions about things who will inevitably have a huge amount of influence over the evolution of the system. That is the heart and soul of Cardano and what really matters. And that's why it has so much value. It's not about some arbitrary feature or functionality. It's about the collective wisdom of a crowd of millions of like-minded people that want to evolve an organic system to become something that can work for the entire world and solve the problems of the world, and are committed to that emotionally, philosophically, spiritually, financially, in their own ways. That is why the value is there. As long as that crowd's there, the value stays, and that crowd's not going away. In fact, it keeps growing and getting larger, and we have the right process to ensure that these innovations are done responsibly. Peer review, formal methods, and the hard fork combinator, these types of things. They work together like hand and glove, and they allow a systematic, methodical pace of innovation for the system. And we thought really carefully and wrote down years ago about how the model works. You have to build in layers. You have to allow ephemeral domains, permanent domains, off-chain processing. You have to introduce heterogeneity in a very responsible way, but yet preserve inclusive accountability. These are not buzzwords. These are things encapsulated in papers and protocol design and now code. And the single most exciting event of our ecosystem, the launch of Goguen, is imminent. It's happening in 8 days. There, thousands of developers are going to start building, breaking, and thinking of things. And that will force faster evolution of the system, more tooling of the system. And over an arc of time, we'll be in a very good position. We never have regressions because, well, people stay. So ask yourself, where are we going to be next year? This same place? No. It'll be a significantly more decentralized and vibrant ecosystem. Where were we last year? Where were we the year before? Look at the growth. Look at the progress. That model, that mindset is the key. And you can absorb everything else. So I hope that makes sense to people. If it doesn't, come to the conference and maybe it'll make sense there. Participate in the hackathons. Maybe it'll make sense there. If not, go camping for 6 months and come back and see where we're at and notice how it's more, and look at the evolution, look at the progress that's being made. Guys, this is an adult project. It's professional. It involved a lot of people. A lot of careers are connected to this. There's an enormous amount of capital invested in this, in infrastructure and other such things. People are really working hard, and they're really thinking carefully because they understand what's at stake. This has nothing to do with Octopus Swap or whatever, or issuing NFTs representing cute stuffed lobsters. This has everything to do with saying we need a financial operating system for the countries that don't have it. That's where we started back in a TED Talk in Bermuda in 2014. I'm going to Kenya in October. I'm talking to Possessia. It's the first time we can actually talk microfinance on a blockchain. It's been a long fucking journey to get there. But that's the point. We built all of this to get there. And we have the right model, the right community, the right thought process, the right scientists, the right engineers, the right evolutionary cycle to be able to satisfy that problem and do it at a scale of billions of people over time. Or you can listen to Reddit, or you can listen to Twitter and basically just say, well, this guy said something, this person tweeted something, and therefore all of that doesn't matter. All the code doesn't matter. The actual running applications come to 12. That doesn't matter. I saw something, and therefore opinion wrong. Okay, if that's where you live in that world. The people here who actually are building and doing don't live in that world. And they're the ones facing the challenges and overcoming the challenges and growing as people, as engineers, as thinkers, and as philosophers. That's what we wanted to start. That's what we accomplished. And that's why we have the value we have. For those of you who don't understand the weird cult that is Cardano, according to Mike Novogratz. And that's okay. We'll show you who we are. The Paul Hamos method. Tell them what you're going to do it, tell them what you did. That's who we are. All right, everybody. See y'all later. If you happen to be up in Wyoming, maybe you'll run into me. Let's see what University of Wyoming can do. It's a tough game. My dad went to Montana State University as an undergrad before he went to medical school. And so he's obviously an MSU fan, and I got to be a University of Wyoming fan. So we'll be rooting for opposite teams. Talk to you soon.